All right. Again, thank you so much for coming to the Unpacking Standards webinar this afternoon. Like to just let you know who's on the call here. I'm Heather Jenkins. I will be one of your folks that is putting on the webinar today, along with my colleague, Jacqueline Carabinas. And then also Kristen Crawford is the main contact for the Department of Education. And she is on this call as well. She just is popping on right now. So we are happy to have Kristen here. And first and foremost, just for webinar logistics, thanks so much to the New Hampshire Department of Education. They are the reason that we are able to do these webinars and have you all sign up. Also, everyone is muted. We can't hear you. We also, because we are in a webinar format, it's much easier for you to ask your questions either in the chat section or the Q&A section. The raising your hand does not work as well in the webinar format. If you want to stay on at the end, we can try to see how we can do it at the end, but for the most part, if you have questions, Q&A or chat. And then tomorrow, a full 24 hours from when this webinar ends, you will get an email. It will have a link to your PD certificate where the webinar of this, the video of this webinar can be found, and the slide deck and some of the documents that we have connected to this. Also, as we finish up, when you log out of Zoom, there will be a brief survey. We look at all of the comments, so any feedback would be greatly appreciated. We have a couple of other standards webinars or workshops coming up, so your feedback could be used for those as well as anything that we're doing in the future. Today, we're going to be focused on unpacking standards and helping you understand how to do that, to discover essential understandings, key knowledge and concepts and skills necessary for your students to demonstrate mastery in regards to those Common Core standards. This is sort of my cue. I'm going to turn my camera off, theoretically, so we can have a bigger screen here. So you all should be able to see a little bit more on your screen, hopefully. So first and foremost, as we're looking at standards, I'm going to pass off to my colleague, Jacqueline, and she's going to go through the next few slides.
Thanks, Heather. I really like to think in terms of metaphor when I'm getting started to think about something that might have a number of elements to it, or I might need to peel back some layers. So I have three quick metaphors to share of one way we can think of state standards and their relation to curriculum in our classrooms and in our schools, and see if any of the three of these resonate with you. So the first example is thinking of state standards like a blueprint with the overarching guidelines and specifications for a building. They're the essential components, any requirements, all of those bits and pieces are included within the blueprint. But when we think about our curriculum, that's bringing it to life. That's actually building the, constructing the building. That's the construction process. It's the hands-on implementation of the blueprint. And in this way, we can think of it like curriculum when we take our standards and we bring them to life in our classroom. Another way to think about it is like a road trip, with state standards are like the destination and key landmarks on a map. They define the educational outcomes that we should achieve. Thinking in terms of a trip, if we have stops planned along the way, those stops are sort of mini outcomes along the way, leading to creating the full trip. But when we think of curriculum, we're thinking in terms of the entire experience. It's, you know, the route you take, the choices you make about the stops and why you're going to make those stops, or what you do with those stops. And so just another way to think about the relationship between standards and curriculum. And the third one is like cooking. So if you think about having a recipe, although I looked at a picture of a recipe box and put that on this slide, and I thought, does anyone really use a recipe box anymore? I hope people do. I get recipes off my phone, but anyway, that picture reminded me of it. That state standards are like the recipe instructions, right? You have all the essential ingredients, just like standards have the content, the skills, but curriculum is the actual cooking process. I think I like personally this metaphor, I relate to it the most because I think of implementing curriculum in like the craft of instruction as, you know, making the shifts and changes you need because of what you've learned over time with about students and about instruction, much like you would do with a recipe and the people who will be eating the food. And so just to sort of anchor us to the standards we'll be focusing on in today's webinar, focusing on the Common Core State Standards for ELA, for math, and taking a look as well at the next generation science standards. All right, we will get started here. Just a brief overview to make sure everyone's on the same page with what the standards are, how they're structured, and then we will spend the majority of our time with the unpacking. So our Common Core ELA standards, they've been around for a while now, and these are the key shifts that we hold on to. Regular practice with a variety of texts, wide range of texts, right? We want lots of different kinds of texts. All of our reading, writing, and speaking is grounded in evidence from texts, and this idea that we integrate knowledge across disciplines, across not just, you know, reading and writing, speaking and listening, but also across social studies, science, math, all of these other places where we do reading, writing, speaking, and listening. So the ELA standards are organized in a really, I always call it neat and tidy, a neat and tidy way. So this is just a quick look at the reading anchor standards. From K to 12, we have 3 clusters of 3 standards each. And the final standard for all grade levels is the same, but it just replaces the grade level grade band, sorry, or the specific grade. So it might say like read at the bottom, read and comprehend texts at a 2 to 3 grade band, or it might say read and comprehend texts, you know, proficiently at an 8th grade level. And these particular standards listed here are called the anchor standards. And so these are sort of the general standard that encompasses all of the ways that standard is sort of reworked for each grade level. So, for example, in the first cluster, key ideas and details, that first standard of reading closely to determine what the text says explicitly, et cetera, this standard is all about text evidence and making inferences. And it's about that from K to 12. It starts in kindergarten saying with support, you ask and answer questions about the text. Moving all the way through high school when we are not just summarizing and analyzing texts, but making inferences across a variety of texts, inciting to support our conclusions. So just a quick reintroduction to how these are organized and how they progress from K to 12. Our writing standards are organized in pretty much the same way, regardless of the type of writing. We know, just jumping down to production and distribution of writing, we have 3 standards that break down how we will produce and share writing, 3 standards specifically that address research, and then that 10th standard, range of writing, is just like that range of reading one. It's the same, but depends on the grade level, the way for how much time or for the level at which it's asking for the range of writing. That first cluster, text types and purposes, is probably the most familiar to all of us because we see that we're writing arguments, we're writing informative texts, and writing narratives. And you know, we sort of keep those in our mind throughout our writing instruction in the year, regardless of grade level. But we do have these other clusters of the writing standards to guide our instruction, as well as the language standards, which help us teach our vocabulary and grammar and conventions and so forth. So our ELA standards in the the typical PDF document that you may get in a binder at school or you might find online, is we organize them into our domains. And so our domains for ELA are literature, reading informational text, as well as writing and language. This one just shows the two reading. They're often represented as RL for literature and RI for informational texts. And then you'll see the clusters. You can see key ideas and details noted there. And then those individual standards noted right underneath. And so just a quick recap of the reading standards, because we're going to dig into those a little bit more later, is it's really easy to think of these in these groupings that we have 3, 3, and 3, and then our range of reading. It helps. I think this really helps when we're going into trying to understand our standards and unpack them for designing instruction, that, when it comes to reading, there aren't as many as it feels like sometimes. We can really think of them in these clusters.
Okay, as we kind of switch gears and talk about math and sort of the key concepts within mathematics as well, we talk about specifically K-8, the mathematics standards. They're all, even K-12, they're internationally benchmarked. The big thing that is that they are, help us provide guidance for that rigor that is needed for students to be able to understand and apply the skills. So it's not only, building those procedural skills, but the conceptual understanding, and they build off of one another as the grade levels go up in grade level, and the rigor gets a little bit more, there's a higher rigor as we go through those particular grade levels. Because the skills are go through each grade level and they are reliant on previous grade levels, there are some key concepts in each grade level that we will talk about that will help us understand what will be where students are coming from and where they'll be going to, depending on the grade level in which you teach. They also are provided with specific topics that link to one another across the grade levels. And the way that the math standards typically work is in a 3-year cycle or period, where one grade level, they might be introducing it, the next grade level, they're working on it, and the following year, they're securing those skills. So math standards are a little bit different in that we need to be really dialed in on what the expectation is for our specific grade level. So we'll go through, there's a link, lots of links on these slides, that you will get tomorrow. And so you can always click on those. But as we go up through the grade levels, the key concepts at each grade level are listed here. So you can see in grades K and 2, the concepts, skills, and problem solving related to addition and subtraction is the focus area for K-2. For 3 to 5, it's the same things for multiplication and division of whole numbers and then fractions. Grade 6, we're looking really at ratios and proportional relationships and those algebraic expressions and equations in the earlier stages. Grade 8, same thing with those ratios and proportional relationships, and we're looking at arithmetic of rational numbers. And then grade 8, linear algebra and linear functions. The information for high school as well. We have focuses on all different areas of mathematics, from algebra to geometry to trigonometry. So they are all depending on the student's track for mathematics in high school. We start with algebra and then moving on typically to geometry and then the higher algebra and so on. For specifically, not even dependent on a grade level, just in general, when it comes to math, the big thing that we want to first really be looking at is that conceptual understanding, right? So when we talk about rigor and we talk about what students need to know, the biggest thing that they need to be able to understand is that conceptual idea. What does it mean to be able to be flexible in our thinking and understand how these concepts relate to one another and not just in a one particular way? The procedural skills in fluency come after the conceptual understanding. This is one of the biggest misconceptions with teachers of mathematics is we are trying to get kids to really just understand procedural, and we want kids to be fluent before they have the conceptual understanding. So they either end up not really being able to do what they should be able to do at their grade level in math because they've just been taught the procedure and they don't really understand it. Or for those students who really they're very quick at procedural understanding, they're going to do really well in the lower grade levels, but then they're going to hit the higher grade levels and they are going to be kind of dead in the water because they don't have flexibility in thinking and those conceptual understandings. They're just tell me what to do and I'll solve the problem. And that's not the way that mathematics works in, as we move up through the grade levels. So when you have both of those, the conceptual understanding and those procedural skills and understanding and have fluency in math, the application becomes easier. But really that conceptual understanding is what's going to help us get students to be able to apply their understanding as well. Much like the ELA Common Core standards, the math are looked at the same way. So we have domains of math or reporting categories. Those are those big areas of mathematics. And then from there, if we look at right now, we're looking at the real number system, we have a number of clusters of standards. And then within that, we have the standards listed underneath them. There are some that have more standards underneath them than others. And when the Common Core standards for math were written, the clusters were thought of as something that they would need to be able to do or to apply. And then what's needed for them to be able to do that is listed underneath it. And just because there's one standard doesn't mean it's an easier cluster or a smaller cluster. They all have roughly the same amount of cognitive rigor, but there might be different things that need to be pulled together to be able to do something. The math standards in the domain progression, just wanted to point out as we go through K to 5, you tend to have for many of those particular grade levels, we're looking at kindergarten's the only one with counting and cardinality. We've got numbers and operations base 10, operations and algebraic thinking, geometry, and measurement and data, K through 5. And then grades 3 through 5 have that numbers and operations fractions. And then it's just, I find it really helpful for teachers to understand numbers and operations base 10 moves into ratios and proportional relationships. Numbers and operations fractions moves into the number system. Operations and algebraic thinking becomes expressions and equations and functions, and then so on and so forth. So this has always been a graphic that's helpful to understand those progression of math standards. The Achieve the Core website is also a really great place to help you understand your Common Core standards. They basically have taken the Common Core standards and for each grade level have looked at the clusters within each grade level and those domains and said, these are your major clusters, your supporting clusters, and your additional clusters. So if you teach math, you can know which clusters of standards might be ones that you want to spend more time on. And then there's others that maybe are some supporting ones. So you definitely want kids to be exposed to them and understand them a bit, but they aren't quite as much time needed on them as your major clusters. And then those additional clusters, they just need some general understanding, and it is not a major cluster for your particular grade level. Just so you know, it is an algebra progression. We, in the state of New Hampshire and in most states, algebra is the one requirement to be able to graduate high school. Geometry is something that some high schools are requiring as well. This is not a geometry progression. It mostly focuses on the algebraic progression. And I know that there is some talk in the math world for data and statistics to be something that's looked at a little bit more as well. So just kind of keep an eye on that, but this can be helpful if you're trying to figure out time spent on specific concepts. This is the second page. It just shows you K to 8, what the progression is here. And then we can't talk about the standards for math without talking about the standards for mathematical practice. Most people are looking at specifically their grade level standards, but these 8 standards for mathematical practice are essential skills for students to be able to have, to be able to understand higher levels of mathematics. So as you're teaching specific grade level standards related to specific skills, it's always good to be thinking of your math practice standards as well, and how you are going to make sure that you are covering those in relation to whatever skills that you're teaching.
All right, let's take a look at science, see how those are organized. So when we get into unpacking, it makes sense where we're pulling them from. The next generation science standards are what we are looking at. And much like the other ones, were organized into domains. So you can see the 3 domains here: physical, life, and earth and space sciences. And then on the next slide, you can see more examples of what you see underneath those are these clusters. Now, they don't necessarily use the term cluster all the time in next generation science standards. They're referred to as disciplinary core ideas. Sometimes it just says DCI because we love abbreviating everything. And so if you see disciplinary core ideas or DCI, just know that those are those core ideas that come underneath those domains. You can also look at, much like we talked about the progression from K to 12 standards in ELA, and then Heather just showed you in math. You can also see how these core ideas progress. The link is here on the page if you've ever gone through the next generation science standards. On the website itself, you can see how it moves through. And if you've only ever seen them on paper and you've never gone on the website to actually interact with them there, I recommend it, because then you can see a little bit more about where things come from, and you can get an idea for more of the progression of the standards and what disciplinary core ideas are the focus in each grade level. And that can especially help you to know where students are coming from, with, what kind of knowledge they could potentially be bringing with them from a prior grade. And we're going to, actually, we don't need to open this one right now. We're going to take a closer look at this particular document later. The way that the standards are organized, they're organized in either topic arrangements, or sometimes they're just arranged by the disciplinary core ideas. But whenever we unpack one later, we're going to open this up and kind of zoom in so you can see all the pieces. But essentially, when you're looking at the science standards, you have a collection of standards at the top that go with the particular topic. And this one is Earth systems. And then underneath that, you have the other sections. Sorry, I lost my words there, that we're looking at for science, and the way that all of these practices integrate. And we'll look more closely at that in a bit. So we have our science and engineering practices, disciplinary core ideas, and cross-cutting concepts. And those 3 categories weave together throughout all of the domains and the core ideas. So one thing that I really like about the next generation science standards is they directly will link the literacy standards that can support the science learning. And so earlier I talked about that cross-disciplinary learning that is central to the ELA standards. Here they make it easy for you to really think about the integration of all of these skills. You know, if we think about science class and we think about kids working together to construct meaning, around scientific concepts and hands-on activities, there is a lot of reading, writing, speaking, and listening that will go along with that. And so here it pulls out the specific standards. You can see along the left, the RI for reading informational text, W for writing, SL for speaking and listening. But then also underneath, it pulls in the math standards. And I can see MP2 and MP5, and MP refers to standards of mathematical practice. And then underneath that, the MD measurement, the third grade measurement standard there. So it's helping you create a link for all of these things so that when you're supporting students learning, you understand the wide range of skills that they're pulling from across all of their content areas to be successful with these science standards. The cross-cutting concepts in the next generation science standards they're exactly what they sound like. You can see them listed across the screen here: patterns, cause and effect, scale, proportion, and quantity, systems and system models, energy and matter, structure and function, stability and change. And they do cross-cut, as they are titled, throughout all of the various domains and core ideas. And it is much like how the standards of mathematical practice kind of tie together all of the everything that students are doing in math, regardless of grade level. The cross-cutting concepts are very similar in the next generation science standards, that you will see that third box that when I was talking about those three categories that go with each of the disciplinary core ideas for the science standards, you'll see it will pinpoint the cross-cutting concepts that show up in that kind of learning, that particular science learning. So you can really link their understanding from unit to unit, lesson to lesson, by creating an understanding of those cross-cutting concepts and how things like patterns show up across multiple settings, cause and effect, and so on and so forth. And the last thing that's we put in here, and it looks just like the ELA standards because they are ELA standards, how I mentioned earlier that at the bottom of that science document, the topic arrangement document, it listed the particular ELA standards that would support that science learning. Those come directly from the ELA standards. And so from grades 6 through 12, there is a separate document that takes those same ELA standards for that grade band, 6 to 8, 9, 10, or 11, 12, and it rewrites them to specifically include the language and the content that would be relevant in science and technical subjects. There's also one for history. And so we just wanted to point to this because sometimes it's overlooked that there are not only ELA standards that can be integrated across subjects K to 12, but there are ones specifically written through the lens of science that you'll see show up as well on those next generation science standards. So you don't have to look in multiple places. All right, I'm looking in the chat and in the Q&A box. I don't see anything right now, but please, if you have a question, feel free to put one in the box. I have them open on the screen here and I can take a look and we can answer them for you.
Perfect. All right. So we're going to move on now to unpacking a standard, and we're going to go sort of through the same thing for each particular subject area, but there's just a few little things in the beginning we want to talk about. So why we unpack standards and what it helps us do. The first and foremost, it helps us determine what needs to be taught. A lot of times as we go through our days as teachers, if we have programs and things, we are relying on that program to cover everything that needs to be taught. And there certainly that is, programs are standards aligned, but it is far more effective for us as teachers to be able to know ourselves what is the actual outcome and what do we need to make sure students know at the end of a lesson or an end of a unit or what have you. So it helps us really understand what needs to be taught, and so that we can kind of pick and choose the things from our programs or from our curriculum that we find extremely important for those students to be able to have information about. It also helps us determine opportunities for scaffolding and to be able to help students along the way. So as we look at a standard and break it apart, there's different sort of levels of knowledge that students are going to need, or maybe prerequisite knowledge that they might need. So it will help us with those scaffolds. And then a lot of times when we work with teachers, understanding the full intention of the standards is sometimes missed. Our interpretation may be for part of a standard, but not the full standard. So it helps us with that. And then obviously it's going to help us plan for instruction and help our students be able to gain the knowledge and skills that are required to be able to master and apply their understanding of a specific standard. Some of the steps to be able to unpack a standard. First things first, we're going to isolate the key words in the standard so that we can identify any critical content or skills or processes that are needed for mastery. The second step is linking that standard with the overall arching cluster of standards. So they need to be able to do one thing, a specific thing for the cluster, and then the standards underneath it linked together to be able to ensure that that cluster and that students have full understanding of what they need to know to be able to, again, apply their understanding for a specific skill. And then the third thing is being able to turn your specific standards into I can statements, and being able to break down the skills so that you can ensure that all the skills and understandings are, that students are exposed to those to be able to ensure that they will be able to have full understanding. We have here an unpacking standard template that we're going to be going through for ELA math and for science to unpack specific standards. First things first is you pick a standard, and then we're looking at the verbs that turn into skills and what students will be able to do. And then we look at nouns and adjectives to determine knowledge and understanding and what students will know how to do and what students will understand. So we're going to go right through this and start with language arts. And we're going to have Jacqueline walk you through unpacking a language arts standard.
All right, thanks, Heather. So here I've used that graphic organizer to unpack this standard in this way. Now, I've used this graphic a lot. I like this. This works for me. I have worked with teachers that have really benefited from using this and this step-by-step process. I've worked with other teachers who this graphic confuses them a little bit because it ends up feeling like more than it actually is. So, certainly after you're learning with Unpacking Standards today, unpack it in a way that makes sense to you. I think that, we'll refer to this graphic as a way to sort of see how we got from point A to point B, because this is essentially what Heather and I would be doing in our head if we were working through unpacking a standard along with teachers. So this is a 6th grade standard, reading for informational text. And the standard is the first one that I was mentioning earlier: cite textual evidence to support analysis of what a text says explicitly, as well as inferences drawn from the text. And looking at that word explicitly makes me think that I want to add the adverbs somewhere on this graphic too, because that also gives us some information along with the adjectives to understand how we're building that standard up in our instruction. So I like to look at the verbs first to see, okay, what is it we need to know how to do, our skills. There's a lot of them in here. It doesn't mean they all need to have their own objective, but I like to pull them all out first. locate, refer, cite, explain, analyze, examine. There's all kinds of things that we're doing here. And I pull out the most important that I feel like this is pointing to. So we're citing, we're supporting, and we're drawing inferences. So those are the key things that we need to be able to do. And you can see how it leads to my objective, that students will be able to comprehend text and explain its intended meaning, referring to details both in the text, so there's my citing by citing, and beyond the text by inferring. And so in that way, I can turn it into something that is maybe in sixth grade friendly language that still encompasses all of the skills in this standard. And then looking even further, well, what is the knowledge that we need to be able to do this, be able to demonstrate understanding of this standard? And then what are the broader understandings, these longer term enduring understandings that this standard supports? That is really our next section here. So if I'm going to cite, I might need to understand I might need to understand citations depending on how I'm bringing this standard to life. I need to know the difference between textual evidence and inferences and my prior knowledge. And then thinking about how this leads to the objective, that I need to know the difference between citing and inferring. And then I sort of reiterate what I said in the first objective. But I also need to know of what we're inferring from combining the information with our prior knowledge and our life experiences with what I've read from the text, but we need to know how those things are different. What's evidence and what comes from our prior knowledge or experiences. So that is the key knowledge for this standard. And then this overall, these understandings, I think of these as the long term, the things that we want students to take with them for the long term, that this standard will support an understanding that when you're analyzing text, you should have supporting statements that include both text evidence and a justified inference. So all of these ways that we've worked through this standard and all of the words we've pulled out, now we have, if you look down the right, a clear understanding of exactly what we need to know and do with this standard, as well as a long-term understanding. All right. So one thing we mentioned earlier, that we want to be able to turn those learning objectives into I can statements, so that students, when we share learning objectives with students, that they have the objective not only written in language that they can personalize to understand what it is they are trying to do and to understand their progression toward understanding, but also to break it down. So if thinking in terms of this being one standard, this really breaks down into multiple I cans. We're starting with, I can comprehend text and explain its intended meaning. From there, we're moving on to, once we can do that, now we can refer to details by citing and inferring. And we move on to making the inferences, and then going even further to state that we understand that when we're analyzing them, we need both the text evidence and justified inferences. So it's everything from the previous slide, but now we've broken it down into individual I cans that might accompany various lessons throughout, over a unit or across, a couple of weeks, and then students can see the way that they are progressing toward mastery. So this is just another example of how I unpack a standard sometimes. If I'm not working with the graphic organizer, or it's just something I'm doing quickly to work through it, I might highlight the nouns and the verbs and just pulling out all of those keywords so I can quickly pull out I cans. This is a reading literature standard for grade 3, standard 5. And this one is talking about referring to parts of stories, dramas, and poems when writing and speaking, and then the language we use to describe those. But then that second part, after the semicolon, describe how each successive part builds on earlier sections. That's something that I think gets missed a lot, is thinking about not just the first part, knowing what a chapter is, a scene or a stanza, and using the correct terminology, but these types of texts, but understanding how these fit together, that how chapters fit together and build on one another to create the story. How scenes function together in their sequence, the same with stanzas, and being able to explain, how one is built directly off of another, or maybe one from earlier, and look at the connection across the text. So I broke these down into I cans to demonstrate how we definitely need to learn these to use the right language, chapter, stanza, and so on. But we also want to include describing how the scene, et cetera, is linked to the prior parts of the text. All right, and heading on to math.
Sounds good. All right. I'm sorry, I'm having a couple of technical difficulties here, so just bear with me for 1 second. I'm so sorry. I am okay. I think I've got it. I'm so sorry. Okay. So for math, what we're going to be doing here is we are going to be looking at a particular standard. We are going to look at the information about using place value properties to be able to understand properties of operation for multi-digit arithmetic. So in doing this, we are going to be looking specifically, that's our cluster. And so now we're going to look at multiplying whole numbers and being able to do that with 1-digit, 4-digit by 1-digit, 2-digit by 2-digit. And the other thing is that's really important here is that we're going to be looking at the use of being able to illustrate and explain the information. So that puts a little bit more information into what we need to do here. Some of the confusions with math and this particular standard is that students are not necessarily secure with their basic math facts or procedural. They're getting a little bit too much of procedural fluency, so they have a hard time understanding this specific skill. Maybe they're not understanding the use of an area model, or they're in, traditional algorithm is being taught a little bit too early, which is actually not a standard until grade 5 in mathematics, or they have challenges in taking a problem that's provided verbally and representing it mathematically to solve it. So as we look here, I'm just going to refresh, sorry. We're going to take a look at this. And we're going to look at, again, here is my standard that we're looking at, multiplying those whole numbers. I do the same thing. I'm starting with the verbs here. So I'm going to multiply. I want to be able to illustrate. I want to be able to use the specific properties of operations. And then we need to be able to explain. As those move across, we talk about the skills that are needed. We need to be able, when we're talking about multiplying, multi-digit multiplication, we need to show our understanding with drawings and use different strategies. And then this is what we want our students to be able to do with that. We want them to be able to multiply whole numbers. We want them to show an understanding of multiplication with illustrations. We want to be able to use arrays, equations and/or other models to represent that multiplication. As we move down here to the nouns and adjectives, this is where we're talking about, okay, we need to understand what whole numbers are. Obviously, we're talking 4th grade, so hopefully we know what a whole number is. But the word digits, the word strategies, place value, properties of operations, rectangular arrays, and area models as well. So we want to be able to know that verbiage. This can also help just so that you can understand as well. This can help students with that are ESOL or things like that as well. English as a second language. just to be able to help with vocabulary and know what vocabulary needs to be unpacked for those students. So I really like that particular section for math as well. The knowledge, this is again, what they need to have understanding or knowledge of, and that is what is a rectangular array, what is an area model, what are equations, different methods of multiplication. So in that, students will know how to illustrate or have visual representations of multiplication. They should be able to describe the steps taken in the process of multiplication. And then that underneath those, this understanding here, these are those things, again, you're taking away from this particular standard. They need to understand place value, need to understand multiplication and property of operations. So the students will understand, they need to understand their basic multiplication facts, how to break those numbers into hundreds, tens, and ones to make multiplication easier. They need to know how place value impacts multiplication and how to use those properties of operations as strategies for multiplication. Ooh, that sounds like a lot. So let's move on to the next one here. The reason that I like unpacking standards so much specifically for math is because we look at this and we say, okay, this standard is one standard, right? We're going to multiply whole numbers, and it seems relatively straightforward. Obviously, if you teach fourth grade math, you know it is not straightforward. But as we look at standards, this is what we're talking about when we say we need to understand a whole standard. Look at all of the I can statements that come from one standard. What students need to be able to do to be able to, understand and apply their understanding and show understanding of a specific standard. So these are all the things that are taught and the skills that are needed to be able to have students apply understanding and be successful with this particular standard. I also wanted to, there's a quick little link here as well when you're unpacking standards. The Achieve the Core website is really great. They have a coherence map. All I did was link the one specifically for MBT. And then I really like this progressions area because it's showing you how students might progress their understanding of this particular standard, so it can help you with your instruction. So I included the link there, but you can map any standard on the Achieve the Core website and it can show you what the progression is.
All right, thanks, Heather. And I'll just add really quick with the math as someone who, I'm very comfortable with ELA, with all reading and writing standards, and that is my world. When I think about the way the math standards are unpacked, I think about how, if you have a math program and you go to a particular unit and it says that this is, a key cluster and these are the standards in that cluster for this unit, breaking them apart helps you understand where maybe the sequence of lessons that's laid out in the program comes from. But then also it can really help you make decisions. Sometimes if you think that you get to a lesson and you're thinking, I'm not sure where I don't really understand how this fits in the big picture. Understanding and unpacking that standard can help you see where that fits and can help you for planning. So just wanted to add that on. So thanks, Heather. So we'll take a look at the science and we'll unpack one of these. So like I said earlier, we have our domains and our disciplinary core ideas listed underneath and then standards underneath those. So for this one, I just used the highlighting example just to show our nouns and our verbs and looking at all of our key words. Now, this particular standard that I unpacked was just the one I did. It's just this first one, but underneath Earth systems, all four of these standards can go together. So the particular standard that goes with the processes that shape the Earth portion, that is that first standard. So if you look underneath Earth systems in the science standards, you'll see the bottom three: the compare multiple solutions, the develop a model and obtain information. And that first one is very specifically to the processes that shape the earth. So I just want to point that out because sometimes the way the science standards are written, they're very wordy. So sometimes it's just helpful to know where all of these things come from. So I look at this, I need to know how to use information from sources. That's an ELA standard, really. I'm providing evidence. I'm back to standard one again. But Earth events. So Earth events tells me that that's something I'm learning about. I'm learning about a variety of Earth events and processes that shape the Earth specifically. But also this idea of quickly or slowly, which is why I'm thinking I really want to add adverbs to that graphic because it's not just looking for evidence that Earth events occur, like an earthquake, for example, but the idea that some of these occur quickly or slowly. And as you know, you look at these other standards as you continue on, there are things like compare multiple solutions. So thinking about how to make something faster or slower. You'll see later that we pull in some math, looking at some data and graphing to understand the rate at which these Earth events might happen. So knowing all of these pieces helps me start to think about all of the various skills as I break this down. All right, so here's our standard again. Heather's going to open this document so we can see it, the full document on the screen, so that, like I said before, it's helpful to see where these all come from. And these the science standards, there's a lot of words on a page. That's the only way to describe it. And so you can see exactly what I was describing earlier, our Earth system standards at the top. The Earth's processes disciplinary core idea is up there. If you look in the orange box in the middle, and if you can see it, where you see ESS 2A, the second one, Earth materials and systems, wind and water can change the shape of the land. That is a disciplinary core idea. And so that is up here. It's a core idea that they are linking to in this particular one, Earth systems. So that's how these all fit together. And then you can see on the left, here are science and engineering practices that specifically can go with these. And then on the right, you see the cross-cutting concepts, those things that are really transferable across a variety of settings and content areas, patterns, change, things like that. And then underneath, I can see all of my ELA standards, math practice standards, and this is a second grade standard. So I see my second grade math standards down there as well. But right now, we're really just going to zoom in on that one particular standard of the use information from several sources to understand how this works. So if I'm unpacking this standard and I'm trying to understand how these pieces fit together, I'm looking for that code, so to speak. So I see where the arrow points at 2ESS11. That's the same coding as that went with the standard that I just unpacked. And so here I can see that exact piece that was up top, make observations from several sources to construct an evidence-based account for natural phenomena. And then underneath that, we see that the same language repeated again from up top, compare multiple solutions to a problem. And so these come directly from, in the science and engineering practices, this category of constructing explanations and designing solutions. And so again, it's just trying to take ideas and link them across a variety of settings so that, our science learning is not in a vacuum. Our science learning is integrated from domain to domain, but also with our other content areas. So for the next one, now we can zoom in and look for that coding again. So these are disciplinary core ideas that could go with some of these standards, but we pulled specifically from these first two for this topic arrangement, I think they call it. So history of planet Earth is a core idea, and you can see it there. Some events happen quickly, others happen slowly. And then underneath, another core idea of Earth materials and systems specifically names wind and water. So you can see where they came from, but then you can also look at some of these other core ideas that go with understanding Earth systems as a domain. And then again, looking at our cross-cutting concepts, like I pointed out earlier, they're showing specifically which standards show these particular concepts or illustrate these concepts the best. And again, just to create that connection across the science learning. So the last thing I want you to notice about the next generation science standards is that sometimes when we unpack a standard, there are still vague pieces. So notice we talked earlier about Earth events, right? So, okay, Earth events, but like what Earth events? I mean, can we just do any Earth event, all Earth events? Which Earth events are we referring to? So all of the standards have a clarification statement and an assessment boundary. And even though it makes everything more wordy, I really like these. I wish all standards or clusters had the clarification statements and boundaries. Um, so this one clarifies that, we could be looking at volcanic explosions, earthquakes, erosion, but it says assessment boundary, meaning if you're going to assess this, we're not assessing quantitative measurements. You might assess, someone might read a student might read a graph or another visual, but the students themselves do not have to provide the measurement. So it's just making it clear. So you can see on the right now, we're locating information, we're using it as evidence, and we're making observations. Again, our ICANNs are broken down and we know what we need to accomplish. And so just the last thing I wanted to point you to, I don't know if any of you have been playing with the AI tool, Magic School. Magic School is a lot of really great tools. One of them in particular is a standards unpacker. And you can paste in a standard and AI will unpack it for you. It is very cool to use as a starting point to think about standards. They also have one where you can paste in a standard and think about generating questions of various levels of depths of knowledge. And again, another great tool, something like standards unpacking is best done like we've just done manually, so you really do the understanding. But it can serve as a starting point if you're feeling stuck and you're not sure where to start. But then examining the pieces closely is always necessary with anything that you're doing with AI. So just wanted to point that out in case anyone is using Magic School. All right, how are we doing? No questions so far, Heather, but I'll keep an eye on the box.
Perfect. We have a couple of sections left. They are a little bit shorter. We are like 3 minutes from time. But we just wanted to talk a little bit about understanding and using depth of knowledge when you're aligning your standards to instruction. So I apologize, we're going to go over just a little bit, but I'll go kind of as fast as I can. All the documents are in here, but we wanted to show you how depth of knowledge folds into this as well. So obviously, when we're unpacking standards, we're figuring out the knowledge, the skills, and the concepts that are critical for students to understand. But we also are looking at addressing that full intention, like we said, of the standard, and then making sure that students are engaged in various depths of knowledge in regards to that particular skill. So we want to make sure that the rigor is high enough as well. Just in general, we have for depth of knowledge levels, there are 4 levels of depth of knowledge. First level is that recall. The second level is understanding the skills and concepts. The third level goes a little bit more to that strategic thinking. And then the level 4 is taking a culmination of all of that and extending your thinking. So just a little bit of understanding about misconceptions of depth of knowledge. It's not a hierarchy. When we're talking about depth of knowledge, we don't want to do all depth of knowledge 3 and 4. Students have to be able to understand those depth of knowledge 1 and have those become more routine to them. To be able to understand depth of knowledge 2. And so we don't want to do all depth of knowledge 1 or all depth of knowledge 2 or any of the depths of knowledge. It's not all depth of knowledge 3 because students may not have the 1 and 2. So we want to be able to vary that and make sure that students have all of those levels of understanding to be able to put it all together, to be able to apply the skills. Again, another thing for a misconception is the number of steps that students need to do to be able to complete a task does not equal the depth of knowledge. There are some times where we ask students to do 5 different steps and they're all depth of knowledge one. So it doesn't mean that just because there's more steps means it's more complex when it comes to the rigor or for the sort of understanding and the cognitive need or the cognitive load of something.
So I'll just continue what Heather's saying again. And, we just have some ways to think about depth of knowledge through the lens of these specific subject areas that we've just talked about. And so I really like how this breaks it down and thinking in terms of what is the difference between using simple skills, moving through the mental processing, thinking beyond the text and the higher order thinking. So, right there in the middle on depth of knowledge 1, it shows the reading doesn't require analysis, focuses on basic comprehension, right? Standard 1, ask and answer questions to understand text. It's right there on the page. You can find it. It's put your finger on it. And that moves into, then we can start to look at where we're moving to next, where now we're summarizing, we're interpreting, we're classifying, we're doing some more mental processing. And you can see at the bottom some key concepts there are noted, just like when we broke down the standards into the verbs. The verbs and the nouns, our concepts and skills are here as well. And so once you have to go beyond the text and explain or generalize and have connected ideas, now students are in a much deeper level of knowledge because we have to pull from many different skills to produce this kind of thinking. And depth of knowledge 4 usually has to do with generating some sort of original thinking. It can be something that is extended over time, but it always has to do with pulling from a variety of areas and generating some new thinking. Lots of deep thinking, deep knowledge, probably a lot of the reading, writing, speaking, listening, all of those pieces are integrated for our depth of knowledge 4. And so just as an example of how the standard breakdown fits with this, here's the standard we broke down earlier. So level 1, that recall and reproduction, I can identify the details and facts. I might say, find a sentence that describes the main idea. And I'm just recognizing specific information directly stated in the text. So there's my level 1. Whereas 2 are skills and concepts. Now we're summarizing, we're paraphrasing, restating, using our own words. And so you can see how that's just a step up from just saying what's right there in the text. To the strategic thinking, making inferences based on the evidence, but also explaining the reasoning, supporting inferences, connecting our details, justifying conclusions. There's a lot more action here that requires those thinking processes. And then to level 4, where we have that extended thinking. We might have multiple texts. We're analyzing, synthesizing pieces of evidence across a variety of texts, combining this information together, generating our original thinking, synthesizing, all kinds of things are happening here. It's a much more layered experience. And so we, when we think in terms of the standard, we keep referring to the full intention of the standard. Standard 1, I always call it the ask and answer questions evidence standard, but it's more than that, right? So yes, we need to be able to ask and answer questions and summarize text, but as we move on in the more, as the standard gets more complex, rather, we're doing much more with those concepts and skills.
Okay, as we're looking at this with math, it's the same sort of thinking as we're looking at depth of knowledge. Again, we're recalling. Depth of knowledge 1 is just that recall. Depth of knowledge 2 is understanding the skills and concepts. Strategic thinking goes with depth of knowledge 3, and depth of knowledge 4 is that extended thinking. So this is just from a more of a math lens. You can kind of take a peek at this in the slides later. I also really liked this one. We've used this in the past with a depth of knowledge webinar. This is has a lot to do with multiple subjects, but I really like it for math because is there a right or wrong answer? We always think of math as there's one answer, there's a right answer, and there's wrong answers. And so this is just a different way of thinking of this when it comes to math and the depth of knowledge needed to be able to have students understand whether a particular question has more than one answer or that there's, what the wrong answer is. When we start having students think of why an answer is wrong, we start to increase that depth of knowledge. So here's just some general information. Again, I'm looking at that same standard, that multiplying whole numbers. And we have the different depths of knowledge here. So as we're looking at this and we would rate them, the depth of knowledge 1 is actually just finding the sum of these here. When we think about depth of knowledge 2, we're looking at using specific digits 0 to 9 and making sure that they can fill this in just to make sure that this statement is true, right? And then as we increase to a depth of knowledge 3, we're looking at this using those same digits, doing the same thing that they had to do with that depth of knowledge 2, make it so that it is the greatest possible total, which again is increasing that depth of knowledge. If we're looking at depth of knowledge 4 for this, we're looking at activities that involve analyzing and synthesizing all this information from multiple sources and applying those models to solve problems and conduct experiments. So this is how the standard that we broke apart earlier will go through with the different depths of knowledge. Here is a resource that we have. Robert Kaplinski is awesome. He has this open middle. He breaks apart a lot of the math standards and he gives you the DOK 1, 2, and 3. DOK 4, again, for most things are going to be involving the activities and using this particular language. So he goes through mostly the first 3 levels of the depth of knowledge. And so these can be super helpful for math teachers.
And then we'll take a look at science. And so again, thinking we're moving from following a series of steps through making decisions, through multi-step tasks that would require students to explain their thinking, justify their reasoning, engage in higher order thinking. And again, just like with the math, in depth of knowledge 4, now we're into the open-ended tasks. There's significant complex thought and it's over extended periods of time, pulling from a lot of different places, making a lot of connections and relating ideas. And this is probably, where we're also really maximizing the relationship between our reading and our writing, speaking, listening, math, science concepts, all of those things together in a depth of knowledge 4 task. So I mentioned earlier that the practices, the core ideas, and the cross-cutting concepts kind of weave together. And this is really the element that creates the depth of knowledge, the higher depth of knowledge for science, is that we have all of these things that work together. And because they all work together, you can, we're using them in our units and lessons to various capacities, depending on what the task or the understanding might be. So when we look at our practices, we have investigation, we have design, but you need knowledge and skills for those. So you can already see under the practices that we have, we already have a range of practices here. If you're focusing on investigation, you could be just following a step-by-step process which is depth of knowledge 1, but you could also be, developing your own scientific investigation to find a solution or solve a problem. And that would definitely be moving toward more of a depth of knowledge 4. So we kind of have those encompassed throughout all of the dimensions. Again, the cross-cutting concepts really provide a way to organize these concepts that show up in a variety of settings and can create kind of like a link between everything for students and their science knowledge. And I would say not even just their science knowledge, but I would say their mathematics knowledge as well. And then I've mentioned before the disciplinary core ideas. They're exactly what they sound like. They're core ideas, but without them or from them, that is where we build understanding, and then we take those ideas and we play with them. We manipulate the information we're learning. We tinker. We try things out. We can generate our own hypotheses and thinking, and move from depth of knowledge 1, 2, 3, and 4, or move across various depths of knowledge to achieve a varied range of tasks. And this is another resource that can help you think in terms of just generally where tasks might fall in depths of knowledge. These cognitive rigor matrices are built across the top. You can see the depth of knowledge levels, but then down the left, you can see Bloom's taxonomy, which we didn't get to talk about at all today because we definitely don't have time. But this is where, when these meet, this is where the cognitive rigor really can be elevated. And so it gives examples of where you might be doing a depth of knowledge 1 activity that actually is all the way at the top of Bloom's taxonomy. You can have a depth of knowledge level 1, recall and reproduction, that goes with create in Bloom's taxonomy. You can have a depth of knowledge level 4, extended thinking, that just lines up with understand or apply. And so it's just an interesting way to see the various ways that we can move students through learning. There are so many different dimensions, I guess is a good way to say it, that we can take them through learning the standards. So when we put all of this together, we're thinking, okay, I'm going to analyze my instruction, thinking about our standards. Does my instruction match what the standard is really asking students to do? That's one question we can ask ourselves. And then when we're planning lessons, looking across, our week of planning, our units, do my lessons match the cognitive demand needed? Am I only staying at a surface level and then moving on? Am I meeting the full range of the standard? And what would a task at that particular level look like, especially as a scaffold to build to the higher level tasks? Then thinking in terms of assessment, how can I assess the level of demand that a standard or a cluster is requiring, and then which ones might serve as the best formative assessment so I can make my decisions for what I teach next. And then carrying on to the scaffolding and differentiation. When I look at the full range of everything a standard is asking to do, what do I need to do to assess readiness? And how can I plan to get all of the students, regardless of their starting point, to the full cognitive demand of a standard? And so just a series of questions to help you with your planning process as you use your knowledge of unpacking standards. All right, still no questions, Heather, so we are good to.
All right, we're going to wrap it up. Here we go. So these are a lot of the Hess cognitive rigor matrices that we were looking at. We looked at the math and science ones. So these are also linked here so that you can see, depending on what your particular subject area is. We have a whole bunch of little resources. We love to give you resources. So any of these will be able to help you sort of interpret or figure out standards. Just at the top here, if you haven't seen the performance level descriptors for New Hampshire SAS, they're grades 3 through 8 for ELA and math, and then science grade is elementary, middle, and high school. And what those are is they have the different levels of proficiency and what students would be doing in regards to that standard that matches with proficiency. So those are pretty cool. And the Lexile Quantile Hub is something that the department has every single educator in the state of New Hampshire can use the Lexile Quantile Hub. Thanks to the New Hampshire Department of Education, those can really help us unpack some of the standards as well as these other sites here. More webinars that we have an iPlatform webinar coming up for both the for LEAs and for the general public. We have an Unpacking Standards workshop, and actually that is a full day workshop. So if you want to be able to spend a full day with us doing some of this stuff, you can sign up for that. And then we have a K-3 Better Understanding Assessments and Standards webinar as well. We also have, I feel like this might be, we have a commonly misunderstood standards webinar, and that might actually be the one on this date. But keep an eye out for the emails coming out. And then again, once you close out of this, you will have a quick survey to be able to take. Sorry about the timing. We went 15 minutes over, but hopefully pretty much everybody stayed on. So we appreciate you staying on, and please reach out to us if you have any questions or need more information about this. And other than that, we will say thank you for coming today, and we appreciate your time.
Yeah, thanks everyone. Have a great week.